Okay, good morning, everybody. Today we're working with pre-algebra on ratios, rates, unit rates. In the Envision curriculum, we'll be assigning items in 5.5, 5.6, and 5.7, the Math Excel. For each one of these, which you can redo as many times as you want. There's also a very helpful little button in the upper right-hand corner on Help Me on this question. Sometimes that will step-by-step you through it. Sometimes it'll take you to a video in the content that can help answer some questions. And then you'll be doing the quiz for each one. You can only take that quiz one time. So be sure that you take the Math Excel until you feel comfortable with the material. The funny thing about ratios, rates, and unit rates is there's this funny debate in the math community about this definition right here. Some people use the words ratios and rates interchangeably. Some people do not. Some curriculums say that rates have a 1 in them. Some people do not. So I'm going to talk specifically about how Envision treats it because that's the curriculum that you'll be working in. They say that rates compare two things. And I think where Envision and a lot of the math community comes from is a ratio is just a proportion of two numbers, like 3 to 5. Whereas a rate would be a comparison of like 3 pigs for every 5 cows. Now that I have these labels in here, they're going to call it a rate. Other curriculums will do other things with that, but that's how I'm going to treat this one. So really, what are you going to do with rates? You're going to treat them the same way you've been treating ratios. You're going to treat them like finding equivalent fractions and simplifying fractions. You could also write this as 5 cows for every 3 pigs. They are the same relationship, but represented two different ways. You can't put an equal sign here because it isn't the same. The labels aren't lined up. Unless the labels line up, we can't put an equal sign there. So really what we're saying here is order matters. Always be careful of order. And when in doubt, table it out. You're going to make your ratio table and line things up. You're going to see a lot of discussion with regards to rates in here. You're going to just find equivalent, and find equivalent, and find equivalent. That's going to be a lot of 5.5. As you move into 5.6, we're going to be talking about unit rates. Unit is singular. That's going to be your clue that it's going to be out of 1. So you could have 3 cups of flour for every 1 cup of sugar. That would be considered a unit rate. Now I could end up with that 1 up here. 1 cup sugar for every 3 cups flour. As long as you're consistent with your labels, I do not care, and you can recognize this as a unit rate within your tables. I will get to an example shortly. I know what you're thinking. Number 1, can I use a calculator? Calc is okay on everything. I do like you to show your work, but we'll take the calculation piece out of it because you are going to be working with some funky numbers. Number 2, why do I care? Let's get to an example. You are going to be asked to tell us to compare rates. So let's talk about Peter can swim 12 laps in 8 minutes. And then you've got Calvin can swim 16 laps in 10 minutes. Who's faster? This is why we care. So I'm going to solve this 2 different ways. The first way I'm going to solve it is by using equivalent ratios. Envision would say equivalent rates. They're kind of interchangeable the way we treat them right now. I'm not going to get into total it, but they're called rates here in Envision because they have these labels of laps and minutes. So I'm going to start my ratio table for Peter. And I'm going to have laps and minutes as my labels. Peter can swim 12 laps in 8 minutes. And then I'm going to skip a couple lines just because of the demonstration that I'm going through. And I'm going to put Calvin here. I'm going to keep my labels in the same order. Now, I hear your question, Mrs. Rohner, could I say minutes and laps and minutes and absolutely, you could have 8 and 12 flip-flop there as long as your labels are flip-flop. Be consistent. So I can compare this two ways using equivalent rates. I could say, well, maybe I want to simplify this and get some simpler numbers. I can divide by 2 and divide by 2. I can do that here, 8 and 5. I can do that one again and get 3 to 2. He goes 3 laps for every 2 minutes. The issue here is I'm not seeing any numbers that are the same. This is our simplest form. And this is our simplest form. But those aren't helping me to relate Peter and Calvin yet. So I'm going to go back and say I want to make one of these numbers the same. You know what? I see this 2 and this 10. I'm going to say, well, I could get 10 minutes. So I know that Calvin can do 16 laps in 10 minutes. Let's see how many Peter can do in 10 minutes. And that would be multiplying by 5 and multiplying by 5. So Peter does 15 laps in 10 minutes. Calvin does 16 laps in 10 minutes. So by that rationale, I know that Calvin is faster because he swims more laps in the same amount of time. That's very convenient. Now let's say, I can hear your question, but Mrs. Rohner, I wanted to get equal number of laps. Well, you could do that too and use that equivalent rate in order to compare these. Let me look here what we got here. I'm just trying to see 12, 6, and 3, 16, 8. I'm trying to find a number that's kind of compatible. The number that's popping up into my mind, you get one in your head. It's almost like finding a common denominator. I'm going to use 24. I see that I can get 3 to 24 or 12 to 24 really quickly. I can get 8 to 24. So here I'm multiplying by 3. So in 15 minutes, Calvin does 24 laps. And here, 12 times 2 gets me to 24. So 8 times 2 gets me 16. Now, in 16 minutes, Peter does 24 laps. In 15 minutes, Calvin does 24 laps. So this is, again, demonstrating that Calvin is faster because it takes him less time to swim the same amount of laps. So here, the larger number told us that he was faster. Here, the smaller number told us that he was faster. So you can't just be thinking of greater than and less than numbers. You have to think about the relationship between them. Either one you pick can get you there, but you have to relate it the correct way. The other way that I could do this is by using a unit rate. I have Peter, and I have his laps per minute, 12 to 8. I'm going to find how many laps he does in 1 minute. Now, here's where your calculator is going to come into handy. 12 divided by 8. Is 12 divided by 8 as a fraction? I'm just going to not try to think at all and get 1 and 5/10. I used my calculator. And then I have let me make sure this is still on. Oopsie. Let me make sure I get Calvin in here and his laps per minute. He's going 16 laps in 10 minutes. I want to know how many laps he does in 1 minute. I'm dividing by 10. Now, you shouldn't need your calculator for that one. 16 divided by 10 is 1.6. So this is that relationship that we saw up here with an equal number of minutes, except now the equal number is 1. And I can still see that he's doing more laps per minute than Peter. He's still faster. That's good. We're still proving it yet again. The other unit rate that you could look at is how long it takes him to do 1 lap. So I'm going to come back here again, and now I'm dividing 12 by 12 to get to 1. So I'm dividing 8 by 12. I'm going to put that into my calculator because I don't really want to think today, and I get 0.6 repeating. It takes him 6/10 repeating of a minute to do 1 lap. Down here, Calvin, dividing by 16, dividing by 16, 10 divided by 16, don't want to think today, 0.625. So because 625 thousandths is less than 0.6 repeating, this is the same relationship we saw up here, where in the equal amount of laps, it took him less time. Equal amount of laps, took him less time. That's why unit rates are really, really easy to work with. Now, if I defined how many, how many laps he could do in 13.5 minutes, this is the easiest number to work with because I could multiply that by 13.5. 1 can be multiplied by anything to get anything. 1 is easy to work with when you're trying to find other numbers. So that takes me to my last example that I'm going to do in this little mini lesson. And I'm actually going to pull out my Envision book, which you do not have because I didn't want to write this out. Okay, if you want to take a screenshot of that, you're going to see this in your Math Excel. You might even see it on the quiz. The Garcia family is driving from San Diego, California to Bar Harbor, Maine. California to Maine. I hope they like each other because that's going to take a while. In 5 days, they've traveled 2,045 miles. Okay, at this rate, how long will it take them to travel from San Diego to Bar Harbor? How can we use rate reasoning to solve this problem? Show how to use numbers. So I'm going to solve this problem 2 ways. I'm going to first use a unit rate because I do think a unit rate would kind of help me along here. So again, when in doubt, table it out. I'm going to put my miles and days here. So they tell me they've gone 2,045 miles in 5 days. Now listen, I'm glad I have a calculator here because I'm going to find how far they go in 1 day. I think that's going to help. So I'm dividing by 5. And I'm going to do 2,045 divided by 5. So I see they're going 409 miles per day at that rate. This is a unit rate right here because it's out of 1. How far? Well, how long is that? I got to go over here to the map and get that information. This is the only place that it's located. So 3,272 miles. Now, the problem is I really wanted to be able to multiply to get there, but I have a sneaking suspicion that these two numbers are related. Not always going to be the case, but this could totally happen. I'm going to take my calculator. I'm going to say, all right, how are these two numbers related? 3,272 divided by 409. Let's see. It's times 8. How convenient. Times 8. It's going to take them 8 days. Very, very